Hello. I'd like to welcome you to another MicroProfile talk. It seems that MicroProfile is popular at the conference, but what is also popular is reactive. I saw many reactive talks yesterday, and reactive is becoming popular for a reason, but let me shortly speak about the reason and why should we and when we still shouldn't use a reactive approach. So mostly we don't want reactive applications because that's just a term. We want applications that have certain aspects that are responsive to users, that are fast, so that users have feedback and they can process high loads of data. Then they should be able to recover from failures, easily handle failures, and even fix them if possible. And they should be able to scale, to absorb more resources if there is higher load, especially in the cloud, where it's easy to get and absorb more resources. Applications should be ready to absorb them and use them to speed up their processing. So this is kinds of applications we look for in the modern world. They are not necessary for every scenario, but for a scenario when we need to serve millions of users or process high loads of data, it's highly appreciated to have such aspects in the application. But then why do we need these applications? It's because, as I said, the world has changed. We need to process more data, serve more customers. In some areas, it doesn't make sense to really focus on reactive applications. If we want to write a simple back office application or a simple query application, it's probably not the best option because it's more complex to write reactive applications than normal applications which we were used to be writing. So we should think about what we are trying to solve. Before I go to the goals, I'll introduce myself, because I forgot that in the beginning. I'm Ondrej Mihalyi, working with Payara most of the time. Payara is a MicroProfile and Java EE application server. And I'm also a committer in the MicroProfile project. And I hope to be part of Jakarta EE in the future. It's just now still waiting on all the processes to settle and all the code could be contributed. And I welcome everybody to join these two because they're very exciting projects and very welcoming for newcomers. We always appreciate feedback, always welcome other views, other opinions, and also experts in areas, especially in the reactive area, where enterprise users are not very educated. And to be honest, also the experts that create APIs are not everybody is well experienced with reactive. So if you have more experience from other frameworks, it's good to provide feedback on what we do in MicroProfile so that we can improve your use case in the future. So now what is the use case? What are the use cases? The first one is focus on user experience. As you would argue, modern applications, or even every application, if possible, improves user experience, and users are eager to use it or happy to use the application. In the modern world, it's very easy for users, especially if there are just regular users using your application from mobile phone, to switch to another application or just forget about your service if it doesn't respond timely and isn't pleasant to use. Another aspect is saving resources. We are running these highly applications that serve many users or process high loads of data. We usually run them in the cloud. And cloud saves our costs, but on the other hand, it also poses pressure to save even more because we pay for what we use, not for what we buy in advance. So if we can keep the amount of resources we use to a low level, we save money. And another side of it is that we sometimes don't need only to save resources, but also be able to absorb more resources to be able to process higher loads and adapt to loads. So if there is more loads, like for example during Black Friday or Christmas Eve, the applications should be able to absorb more resources to be able to serve more customers. And in times when the load is not needed, we again want to save money to release the resources and adapt to that. And this leads to the realization that reactive applications, in order to be really reactive, they need to be distributed to be able to absorb more resources horizontally, scale horizontally, because scaling vertically on just small number of instances is limited. We need to be able to absorb more instances, more CPUs, and go widely to a distributed scenario. And that's where microservices fit in, because they are basically patterned to distribute the system into small services that can be still running on one computer, but they are easy to distribute on many computers, or even scale to run on more computers, more instances of the same service. But then we have to think about handling failures, because distributed programming, which is inherently tied to microservices and to high scalability, also creates more failures, because there's networking involved and also synchronization across multiple individual components. So these are the things we need to think about. And with part of them, MicroProfile helps a lot. With some of them, MicroProfile is on its way to help, but not really there. So I'm going to explain the current status of MicroProfile and the plans, and what we can do about it now with the current technology. So MicroProfile started as a microservices framework, or a framework to help with microservices primarily, not as a reactive framework. So it's not on par with, for example, Vertex or other frameworks that are specific to reactive applications and provide mostly reactive API. MicroProfile is more general. It tries to not stand in your way, just to provide tools for you to build what you need. So it offers a couple of specifications. Most of them are general. Some of them can be really used to your advantage when building reactive applications. And just to summarize what's already there, what is geared towards reactive programming, it's asynchronous REST APIs, CDI events, and to some extent we can also include monitoring and health checks, which are not technically part of the code, but the API allows you to expose information about your service, which can be observed by other services or infrastructure to react on either failures or to react on metrics that say something about the future, and allows you to expect some failures in the future. So you can also automate your infrastructure to prevent failures, or record enough information to prevent them in the future. So, as you saw, there were quite many specifications, but I didn't say much about them because they are not geared towards reactive programming. Reactive programming is just slowly getting into MicroProfile. And with MicroProfile aligning with Java EE 8, we will get some more features automatically. This is going to happen in just a couple of days. It should be this month. I don't know the exact date, but it's already scheduled. And with Java EE 8, we'll get improved support in REST client, and also server-sent events, which are very convenient for reactive programming because they don't require waiting for all the response. It's possible to use server-sent events to send the data as they are available. It adds asynchronous CDI events. and it's very close to finish support for, in MicroProfile, it's very close to finish support for fault tolerance interceptors. There's a very nice fault tolerance specification, which now works only with a blocking code, so it's not very usable in a reactive scenario, but with just a couple of enhancements, it can support completion stages and other reactive APIs to wrap your code into fault tolerance interceptors. And what's going on recently is we're adding support for reactive streams, thanks to mostly to James Roper, who had a talk about this yesterday. And hopefully during this year, or by the end of the year, we will have at least first version of support for reactive streams. Until then, we need to add some pieces ourselves. So we're going to add RxJava to supplement reactive streams, because RxJava is a reactive library that helps building reactive pipelines, and it also implements reactive streams API, which is a common API across multiple libraries and the multiple frameworks that support reactive programming, to really tie them together if we want to combine more of these. And on the UI level, we choose, or I chose React.js, which is quite simple for small UIs, and it fits well to reactive programming because it makes it easy to respond to change of state and automatically refresh the UI. So the demo application consists of two services. One is data producer, one is data consumer, which also sends the data to the browser. And it uses first server-side events to send the data to the browser, so that the browser doesn't have to poll the backend. It will just open the connection and listen to any event that comes. And to get the data, we need to connect the producer to the consumer. And for that, I chose Kafka, which is very nice and easy to use messaging system that is very convenient for reactive programming, because it's easy to use, it's distributed, so it doesn't have single point of failure. It can be scaled easily, and it also supports back pressure, which is important when you send just messages asynchronously and the other party is not able to process them quickly. And to tie Kafka to MicroProfile, you have many options. Like you can use the Kafka API directly. You can also use a CDI interceptor, CDI API, which is available as a third-party project somewhere on the internet. And if you use a system or application server that also supports at least part of Java EE, and that is JCA, which is a connector architecture for Java EE, you can also use cloud connectors provided by the Payara project, which theoretically work with any application server that supports this architecture, but they were tested only with Payara as far as I know. But they are open source, so it's easy to fix them. And they're very simple. It's just a couple of lines of code to create the bridge. And to complete our application, we need to get some data from an external service to make it more real, so that we don't need to simulate the data or somehow generate it. And I chose to get the data from Bitstamp, which is a Bitcoin exchange that has a very nice to use API, and also provides an API for WebSocket, so it can send data to me compared to the other way around. I don't have to, the application doesn't have to poll, doesn't have to ask for data. We'll just open the WebSocket connection and get any information. And we use it to get information about current transactions. So every time there is a transaction on Bitcoin exchange, we get a notification. We process it with data producer, turn it into a Kafka event, send it through Kafka to another processor, and then the processor sends it to the browser via servers and events. So for this to work with MicroProfile, we need to add some things. I mentioned the libraries, but we also need to have some support in the MicroProfile implementation. And this is where you need to understand that MicroProfile is just an API. It's like a reactive streams API, but with reactive streams you can't do much. You have to have a library that supports more than reactive streams, that supports operators, so that you can build pipelines. With MicroProfile, it's also good to have something more than just the standard API. And ideally, MicroProfile will grow to cover all the necessary functionality. But right now, it's good to look for other functionality provided by implementations. And one of the implementations of both MicroProfile and Java EE 8 is Payara and Payara Micro. And I'm going to use the full Java EE API or parts which I need in my application that are also in Payara Micro and also in Java. And Payara Micro then demonstrates how MicroProfile and Java EE work well together. They come both, or they have the same base. Mostly the people who work on MicroProfile started with Java EE or were heavily involved with Java EE. Now more and more people join MicroProfile outside of Java EE world, which is good because we have different perspective. But still, we have a focus on being compatible with Java EE. Payara Micro also adds Hazelcast for distributed memory and also distributed messaging. But this is what we don't need. We only may use it if you want to simplify the messaging. For example, if we don't want to start with Kafka or just want to mock Kafka, we can use Payara Micro annotations to send messages through the Hazelcast to another instance in the cluster. Okay, and now we are at the demo. So let's show what I prepared. This is a quite boring application, to be honest. At least as it is now, because I turned off the producer. So the application is just a front end showing the current exchange rate, and I hope it is changing. Most of the time there are some transactions at the it seems I'm not connected to the EC France. Need to connect. Okay, so sorry for the interruption. I should have tried it. It worked yesterday. I didn't think about trying it today. So yes, okay. So now the rate should be refreshing, and this is just to demonstrate how you can create a reactive pipeline when you want to access a service from your point, not reacting to other services, but if you want to start an impulse. Yes, it's changing. So we're polling the backend that's in turn polls the service and gets the data. This is not very interesting. What's more interesting is the other part, the part with Kafka, which is more reactive. And for that, I'm running Kafka in the backend, just one instance, because I don't need the whole cluster. And yeah, just to do the show, I'll start Payara Micro with the data producer application, and it's just an executable jar file. It is one of the ways I can run my application and package it with Payara Micro. It's simple to start, not so easy to maintain, because if you want to update the server Payara Micro, you have to rebuild the whole application. There's also an option to keep the application and the server separate and run them on command line with passing your application to it. And for the Kafka connector to work, we also need to pass the Kafka resource adapter provided by the Cloud Connectors project, which is another, let's say, application, another package we need to deploy. So we have two things, the resource adapter and the application. But now, before I package them all together into one executable jar file, I started it, and we see that we are getting messages from Kafka. So now where is it? Now we see the difference. I'll refresh it so we see how it goes. And every time there is a transaction on Bitcoin exchange, we get notified through WebSocket. It goes through Kafka, through server to send events to our application, and application displays it. The thing is, it's not only one instance of application, but we can also, let me make it smaller. We can run two pages, and because we don't keep the data for the session, we keep it for a whole application. It sends the data to all the consumers. So it starts with the data produced by the service and ends in every browser, every listener. And this is due to RxJava and also JAX-RS server-side events API, which I use to build workflow or data pipeline to automatically notify consumers. If there are no consumers, the data is basically ignored because there's no way to prevent the outside service to send the data, and the producer doesn't know if there is some consumer on the other side, so it sends messages to Kafka, but then data is thrown away if there is no page open. And this is handled automatically by RxJava, where you can choose strategy how to handle back pressure. If I open some code, where is it? Kafka publisher, Kafka consumer, and yes, I wrapped the RxJava flowable into a simple class that initiates the flowable and fills it with incoming messages. So there is a bit of boilerplate because the MicroProfile isn't ready to easily integrate RxJava, and this is required. But then you can wrap it and use it in other places of the application. And what I'm basically doing is creating a flowable that provides me an emitter, which I can use to pass the data to the flowable. And by deciding to use the back pressure drop, it means that if there is no consumer on the other side of the flowable, the messages are just dropped and forgot. We can also choose buffer to buffer the messages until there is some consumer, but that may get unwieldy because if there is no consumer, the buffer would be just growing. And on the other side, we have a resource. What is that? Which is a server-sent resource. It looks like a REST resource because JAX-RS is, the designers of JAX-RS were very clever, and in fact, server-sent events very much look like REST calls. In the end, they are both HTTP calls. Only REST supports multiple methods, while SSE is only GET, and then you get messages. But the messages are basically an HTTP response, which you can read before it finalizes. So you can parse the parts of the message and react to individual chunks, compared to REST response, where you need to wait until everything comes. And the main change here is in the JAX-RS API is the type of data it produces. So it sends server-sent event type of data in the header, and then the client knows that this is server-sent events. It should expect data in some format. It's always string, and it needs to look for pieces of data. And then it can process them one by one and not wait until the end. And here it gets quite easy because we are using a broadcaster, which is a special thing in JAX-RS, which allows to send incoming data to all the server-sent event clients. All of them that are connected to this broadcaster will receive the data. So this is how it works behind the scene. When I open two browsers, I didn't have to do much in the code. In the code, I just created a pipeline to process the data. And then when another client is connected, it's just connected to the broadcaster in this method. That's it. And the broadcaster does all the real work. The broadcaster sets up a reactive pipeline, processing messages from Kafka, turning them into server-sent events, and then publishing them to any registered server-sent client. So again, some boilerplate and some configuration. We specify JSON type for the events so that the client can expect JSON. And here we just log information, and we call an operator from RxJava to map this into server-sent events. And this is just a code that creates the server-sent events. It also specifies the type to be JSON type and passes the data. That's it. And finally, we also close the broadcaster. If there is some exception in the flowable, we will also close the broadcaster and close all the connected clients. And the important thing with reactive and RxJava is to call subscribe at the end. And this is what you have to remember, because if you don't call it, it will not do anything. It's the API is lazy, so you have to create or have to ask for the data. Otherwise, in the vision or in the how to say that, to follow the reactive principles, the API tries to, or the technology tries to reduce all the computations. So even if there is data, it will not call the reactive pipeline if there is nobody interested, to save resources, to save memory. And only when you subscribe to it, you can subscribe multiple times, and then all subscribers will get the information. But it's very similar to Java 8 streams, although it's reverted. The data pipeline is executed only when somebody requests it, while in Java 8 streams, the data pipeline is executed when there is something incoming. When there is nothing coming and or everything is filtered out, it's not executed. But with reactive approach, you don't even execute if there is something coming, unless there is something listening. And if there is something listening and there is also something coming, then it goes through the reactive pipeline. Another part of the application is working with Kafka. And this is where I'd like to show how these mystery letters JCA work in reality. JCA is a technology which is basically behind all the JMS adapters, which are not, or for the brokers which are not part of the application server but run separately from application server. And there are many messaging brokers, so application server obviously doesn't support all of them. Usually an application server has support for just one messaging system and allows plugging in resource adapters to bridge to other messaging systems. Some of the very widely used messaging systems are ActiveMQ or RabbitMQ. They provide support for many protocols, but in Java EE, there's JMS used for as a standard protocol to access them. But you can also plug in other protocols. The only thing you need, you have to have a resource adapter for that protocol, which is provided for a couple of messaging systems by the Cloud Connectors project. And the difference is also in the interface you get in your application. Normally you get interface specified by JMS. Here you get interface specified by the connector. So parts of the code are very similar to message-driven beans in JMS, where you specify connection factory. And let me show you the subs consumer first. This is where it's very similar to JMS message-driven bean, where you specify some configuration using message-driven and annotation config properties. These are properties that you can specify in your code, and you can also specify them on the application server, so you can externalize them from your application. And what is different is that you have a different listener. In JMS you have I think message listener, and when we use JCA Kafka connector, we have Kafka listener. There are a couple of other connectors for mostly cloud services like Azure messaging service, AWS, SQS, I think, and some other, and also Kafka. And all of them have slightly different API because they are not standard, and they provide their own SDK to connect to them. So it's a bit different in every connector, but more overall it works the same. It plugs into the application server and it uses the threads and thread pools and resources in the application server and prepares everything up for you. So you can use the context, the security context, dependency injection context in your code. It's just the interfaces are a bit different. And here, yeah, the difference is the interface. Then there is on record annotation, which is provided by the Kafka adapter, and then we receive consumer record. And consumer record is not provided by Kafka adapter. It's part of standard Kafka API, so it doesn't wrap the messages into some other things. It just provides you what Kafka would provide you if you connect it directly. And then to separate it from the rest of the code, it's good to use CDI events. And even better to use asynchronous CDI events. I'll make it a bit bigger. So then what it gives you, you can exchange the underlying technology just by relying on CDI events, and something else can trigger the same CDI events if data goes not through Kafka but in the cloud through, for example, Amazon SQS. Or if you want to test it or quickly develop, you can also use CDI event bus in Payara if you have a cluster of Payara microservices. And they all run Hazelcast, so they all connect to each other automatically. You don't need to have, you don't need to do anything about it. You just need to add Payara API as an API artifact in your project, and instead of firing the event here, you would use where's the code? You would use outbound annotation and inbound annotation to receive the event. So you wouldn't have to use the Kafka consumer, Kafka publisher. You would just throw an event throw an outbound event when you want to send the data, and listen to inbound event when you want to listen to the data. That's it for now. If you have any questions, I have some t-shirts for every question, or even just take a picture of me and show me the tweet, or just give me feedback about MicroProfile. We'll be happy to have you in the community. Yes?
The examples are really useful that you showed. Are they going to be available after the...
Yes, they are in the repository. There's also a link in my presentation to the repository. So I hope you'll be able to find the presentation at least. If not, just contact me. I'm there on the internet. Just look for Payara and you will eventually bump into my contact. Yeah?
Router file that you're using to connect up to Kafka, is that provided by Payara or provided by Kafka?
It depends. It's provided by Payara team. It's part of Payara GitHub organization, but the source code is separate. And it also has separate release cycle. So currently I'm using a snapshot version because there is a bug in the main version. Yeah, but it's part of what we do, but it's not part of the Payara source code. It can be used by any application server. I know that people used it with JBoss or Wildfly. They hit some issue, so we recommend it to provide a fix because we don't have time to fix it for all servers. But the source code is there if you want to try it and contribute so that it works in your application server that you use. We'll be happy to accept the patch.
So it's this connector, the Payara connector. So currently work with Kafka. So when we have done a MicroProfile reactive, so do you plan to adapt this and to use MicroProfile?
Yeah, I was thinking about this privately. So to be honest, there was no discussion in the Payara team, like widely in the Payara team. But I was thinking about this in terms of how it relates to MicroProfile, and I think it makes sense to make it as an underlying technology, as a pluggable technology, where Payara implements the API and maybe uses Hazelcast as a default messaging service, but allows you to configure another technology and also a JCA adapter to send the messages through. But in the end, it will provide MicroProfile API to send the messages and receive the messages.
Right. In this case, you do not need to expose the Payara's API. You can directly use the incoming of
Yes. Yes, the API is provided by Kafka client and Kafka API, which is provided by the Cloud Connectors project. So you need to have some more API than just Kafka client to plug into the JCA, but there's no Payara specific API. You can just take the API and put it into any.
If you go out, I saw the Payara API.
It's a pack. Yeah, it's a package because we had to name the package, but it's not part of any. Yes, it's because we had to give it the package name. It's like Eclipse org.eclipse, but it's not related to Payara internals.
Oh.
It's just a package name because we created the project, so all the packages have fish Payara in there, but it's not really tied to Payara. It's just in the code. So it doesn't depend on anything in Payara.
Yeah.
If it if it makes sense, or maybe to Jakarta EE, I don't know, or just to some more common project. Right now we are running the project, but if there is some more interest, we can donate it to a more general project. Like there is Apache Delta Spike to collect all the CDI extensions. There could be another project to collect other extensions to MicroProfile or Jakarta EE. So we would be happy to donate it. And then change the package name. If we donate to Eclipse, then it will change to Eclipse. Okay, so thank you. And for all those that want to have the t-shirt, just come back. And if you still want the t-shirt and you haven't asked a question, just tweet about your